values for sine and cosine.
That's how you
So,
read it.
Yesterday, we had two special right triangles, correct?
Yeah.
Yes.
What were they?
45, 45, 90, and
90.
30, 90, and the 36.
60, 30. If this side length is 1, this is 1. Yeah, they're the same.
Oh, yeah.
Right? Then that, what's this? 1. You remember? No.
Oh, wait. 1 root 3.
That's one way to do it, yeah. One squared plus one squared is 2. Square root of 2. So you can use the Pythagorean theorem still, or you can just know.
3.
There you go. Okay. Now, what would happen if I did this?
The world would explode. 5.
Same triangle.
Oh, those would go to the
45, 45, 90. But instead I put the 1 here. How would I go from this to the legs?
Are they both for 1? Square 1.
Okay, here, I multiplied by a square root of 2, right? So how am I going to go the other direction?
The root of 1.
Sorry. Divide by square root of 2.
So you can't
Okay, so let's fix it.
1 root 2. Root 2. It's going to be 1 root 2 over 2.
And then this one would be root 2.
Oh, that was the thing.
So you can go both directions. Just know the ratio, root 2. Yeah. Okay.
Kendra's here.
The other one you mentioned was the 60, 30, 90. I'm just kidding, it's 30, 60, 90. If I give you the short side, which is opposite 30-degree angle, you remember the ratio for the long leg. 1 times
Root 3.
root 3. And then for the hypotenuse,
only 1 root 3 because it'd be that, but 2 times 2.
okay. So, 30, 60, 90 has root 3 in it. 45, 45 has root 2 in it. All right, same issue here. If I put 1 on the hypotenuse, and half, divide by 2, right? And then this would be root 3 root 3 times 1/2. Root 3 over 2, right? We're going to use that information to build what's called a unit circle. The unit circle is going to help you memorize a bunch of values for sine and cosine and tangent. Right? Instead of having to count keys. So, keep these in mind. Now I can change it. I'm going to draw a set of coordinate axes.
You're going to draw, you're going to put it on the screen.
Yeah.
And I'm going to put a 45, 45, 90 triangle in there. And it's going to be radius.
Why are you choosing that 0, 0?
Remember, we always position our angles at 0, 0, a vertex. Right? I'm changing this because it's going to help us build the unit circle. If this is radius 1, or if this is, sorry, hypotenuse 1, that means we already determined root 2 over 2 and root 2 over 2, right? Because this is a 45, 45, 90 triangle. What are the coordinates of this point? 2 over 2 over 2. If I make this our reference angle, what is the cosine ratio adjacent over hypotenuse, correct?
Yep.
And anything over 1 is just itself. Guess what?
So then would that mean the sine
Cosine
is
45
y?
is root 2 over 2.
Yes.
What's the sine?
Root 2 over 2.
Also root 2 over 2, right?
And the tangent gives
If we make the hypotenuse 1, right? Then our coordinates give us sine and cosine and sine. So this is, what angle is that? 45. That's 45. So we could put 45.
and the tangent gives you 1, 2.
Sorry. Yes. You bet. What? Dropping like flies. I know. See you later.
Jeez, bye.
Good riddance.
Yay.
That's
Let's
on
go
Harper.
away. And now I'm the only one.
Nice.
David's a loner.
Keep praying.
Do you understand this?
What? Will decrease.
I used cosine and sine along with the coordinate plane, is what I've done here. Okay.
So like, when your hypotenuse is 1, will your cosine always be the x value?
Yes.
Or yes, always.
That's the beauty of this. The cosine is always the x value. So if I have cosine, a 45-degree angle here, anywhere, it doesn't have to even be here. I can just set cosine 45 somewhere out here. I know that the values are 2 over 2. We can do the same thing with 30, 60, 90s, etc. Okay, so let's look at something like this. This is a 30, 60, 90 triangle. What did we say this was? 1/2? And this was root 3 over 2. Right? So 30 degrees is our reference angle. What are the coordinates at this point?
Would it be a negative root 3 over 2? No, because circles there.
It will. We'll get there. What's the cosine of 30? What's cosine 30?
1 over 2.
Cosine 30 is
Oh,
root
yeah.
3 over 2. Sine 30? 1/2. Okay. We will, yeah. Yeah, this will be a negative. We'll get there. Okay, what about tangent? Yeah, opposite over adjacent, right? So if you know coordinates, you can still divide 1/2 over root 3 over 2.
So would it be easier to make that root 5 over root 3 over 2?
I'm twitching. I just can't handle the decimals. Yeah, when you do the fraction math, copy dot flip, you get 2 over 2 root 3. Take the root 3 out of the denominator, you end up with root 3 over 3. So you can always just do that because you don't have to memorize anything for tangent. It's always the sine over the cosine, or the y over the x.
The tangent of 30.
bottom and up top. 3 times root 3 is 3. So that's kind of the idea of the unit circle, is to be able to get all these values straight out without having to use a calculator. Okay. So let's fill it in. I'm going to do a blank one. So here's the unit circle
Oh no.
that you're going to have to use. And yeah, it looks like a lot of information, but there's some patterns here that make things really nice. This angle is 30 degrees. Okay, what are the coordinates of this point?
3 over 2 and 4 over 2.
Because we can build a triangle right there that's 30, 60, 90, right? And get those coordinates, just like I showed you in the last slide. So what's the cosine of 30? Root 3 over 2, sine 30. Tangent, 1/2 divided by root 3. And then you do that. This angle is 45. What are the coordinates at this point? This is where they match. Yeah. Cosine,
Root 2 over 2.
sine, tangent, divide. Right?
So tangent? No, never mind.
This is only when the hypotenuse is one.
Yes. This is called the unit circle because these are all, this is the radius of one.
So how often is it that the hypotenuse is just one?
Well, the beautiful thing is it doesn't matter. It actually doesn't matter what the hypotenuse is because the ratio still holds. Right? So this will always be the same answer no matter what the hypotenuse is.
Right?
We just use the hypotenuse of 1 because it's very easy to see. Okay, this angle here is 60 for my coordinates.
Half
Yeah.
and root 3 over 2.
What are you reading from?
The unit circle.
Look at that. We switch. Remember yesterday? We talked about that. Just
yeah.
boom, they
Need a
switch.
angle.
Cosine 60, same as cosine 30. Or, I mean, same as sine 30.
Tangent for that is root 3.
Let's fill in this point. If the radius of the circle is 1, this is 1, 0. So cosine at 0 is 1 for sine 0, 0. Go up here.
0, 1.
You start to see how useful this can be.
What is cosine of 0?
Cosine of 0.
Math.
I'm trying to figure out how to explain this right. So
Math.
you don't know the graph yet. So I'll think about it. Again, I don't want to throw so much in it. It's beyond where we're at. So, okay, so these are all the numbers you have to memorize. 0, 1. Okay, so you have to memorize 0, 1, 1/2, root 2 over 2, and root 3 over 2.
And then do they
That's
just
it.
Everything else is,
flip them?
all of these are just make opposites. But, okay, so this whole circle is built off this one quadrant. Right?
So if we laid this over a graph, would be a lot easier to look at.
Possibly. That's fine. Okay, so if we look at this right here, this angle is 90 plus 30 is 120. So it goes from here to here. Right. Here's the nice thing about this, coordinates. Negative 1/2. This is in the negative x, and still positive root 3 over 2. Okay. So you have the same numbers because it's symmetric. You just have a negative because it's the negative x. So cosine of 120, negative 1/2 cosine of 120. What about this one? That angle is 240.
So that could be negative 1/2, or negative 3/2.
Negative 1/2, right? But then it's a negative y value then, but the same numbers. Positive x, negative y. And this would be 300. So you kind of see that pattern, right? The symmetries. What other patterns do you notice?
Everything quadrature is x negative.
Okay. And quadrature. So x's are negative here,
Quadrature would be x.
x's and y's are negative here.
And quadruple is x positive or negative.
What is that number?
0, 1, 2, 3, 9,
0. Okay, so the pattern is 0, 1, 2, 3, 1. So the sines, and then the cosines go from 90 to 1. There's another pattern you can memorize, right? And note the circle or the angle maybe 30, 45, 60, 90. Okay, all of those correspond to the special right triangle, 0 and 45, 30, 60, and 90. You okay with that? I'm going to put a complete one up
Do you have an explanation for cosine
here. Here's the full on.
Whoa. It's on class.
Okay.
I posted this on Google Classroom, right? So you have a handout for it. What I want you to notice here, the degree measures are all there. You do not know what that means yet.
Is that 7
7 power 6, pi, 5 power 6. These are called radians. I will teach that to you after break. Okay? Don't worry about it for now. For now, you're just worried about degrees and the coordinates of all the points. Okay? Mason, quick. What's the cosine of 225? I forgot that exists.
Negative 2 over 2.
Negative root 2 over 2.
Yeah, negative root 2. Excuse me.
Kyra, what's the sine of 330? Okay, here, I'll do that. Yeah, it's. All right, everybody. What's the tangent of 90?
90. 1. No, 0.
Why are the
It's a
ends?
math error. Math error.
It's over time. So you will run into that little caveat. What's the tangent of 0? It's 0 over 1. So 0. Right, so keep that in mind. The difference. 90 dividing by zero is still a no-no, and it always will be. This is not your private study. Any questions?
I know Presley like they would be here for 2 years.
That's okay. James is gonna go into calculus next year, we're prepared.
Yes, really.
Yeah.
That's a shame. It's the length home map. It always looks the ones I put down, this is going home. Yeah, show it to me for a second. Look at this blind people can see. Yeah.
I'm checking to make sure I've covered everything.
Here's today.
One more.
Oh, I know.
Here's yesterday. Here's Wednesday. Just started duty.
Now I know random aspects. Seriously.
All right.
Oh, it's so complicated.
Let's find the values of the 6 trig functions. Oh, God. Kind of review.
All you gotta do is know the numbers on the clock right there. Yeah. They're all classified.
For angle. Standard position. Okay, there's a lot to these, so.
For angle theta.
If the point
That one's really fun.
it's just wordy. Showing you these because they're really wordy. They're not very hard. They're just really wordy, and you need to interpret it and make a math product. Find the values of the 6 trig functions for angle theta in standard position if the point with coordinates 5, -12 lies on its terminal side.
Exactly.
Matches the starting point. So, where's 5, -12?
That one.
Yeah, there, yeah. 1, 2, 3, 4. Oh, I could. It wouldn't be hard at all. So basically what you have, angle theta is in standard position, and its terminal side there.
So the terminal side is right.
Yes. The terminal side is the hypotenuse of a triangle. That's the terminal side. This would be the triangle generated by that point. Here's angle theta. So we have, how long is this length? 5? Well, 8, 12. How we calculate hypotenuse? Diagram here. The negative denotes that it's going to be, it's below the x-axis. It's not a negative length per se. It's a position indicator. 45, 144, 9. Oh, look at that, special right triangle, 5, 12, 13. You think I would plan that? 3, 4, 5 is a special right triangle. 5, 12, 13 is another one. So what is cosine theta? 5 over. Yeah. Sine theta? Negative.
Yeah.
Cosine tangent? And then we can go into secant.
Oh, God.
Over.
Cosine?
I think that's gonna make it 12. Sine over 12. Negative 12.
Negative 12.
Why would it become negative 13?
Fraction,
Negative
there's a
doesn't
negative on here.
Oh, okay.
Right. Okay, there's your 6 straight function.
Would it be negative 5?
So 5 is positive.
Negative 12.
Yeah.
Oh, yeah, it is. Okay, so that's it. That's what that whole mess is asking you to do. It's the same thing we did a couple days ago.
That's like,
Are we good? Can you handle this?
Maybe.
I hope so. If not, each half with. You have the unit circle handout in class.
sorry, I'm gonna show you.
Use it. There will be a point at which we have a quiz to see if you have memorized the unit circle.
Oh, God.
Okay.
Yes. You could have spelled something with 10 minutes to spare.
The quiz will probably be next semester. Okay, unless I get it out. Here. So your final, you can put this on your blue sheet. You can use it. Okay. Next semester on all your tests, you can still have the unit circle on your blue sheet. We will have a couple of memorization quizzes for it. So it takes you a while to memorize things, but it's you know those patterns. You have about 10 minutes. Use your time wisely.
I feel like once we get it all right, then we shouldn't have to take it and then everybody else can.
Yeah.
So what you're telling me